Now, in this part, I'm going to present you the basic terminology and classifications for ecosystem services. All this time, we're talking about ecosystem services. But how are ecosystem services defined? And what attributes they include? Many similar definitions came up in technical and scientific literature during the years. The most recent and commonly used is by Burkhardt et al. In 2012. According to this definition, ecosystem services are the contributions of ecosystem structure and function in combination with other inputs to human well-being. This implies that mankind is strongly dependent on well-functioning ecosystems and natural capital that is the basis for a constant flow of ideas from nature to society. This can be thematically presented by this infographic made by Robert Costanza et al. In 2014. This graphic presents the natural capital as the necessary underlying layer for the social capital, which includes built and human capital. It also shows that human well-being cannot be achieved directly from the use of the natural capital. Thus, human well-being is presented here as the result of the interaction among social, built, and human capital with the natural capital by the use of ecosystem services. We must mention that the term ecosystem services usually includes the supply, potential supply, demand, and potential demand for services by one or more ecosystems. To better now understand the previously mentioned terms and the following parts of the presentation, we are going to deal with some more definitions and the relation among them. We have already used the term natural capital, but how natural capital is defined? Natural capital is defined as the elements of nature that directly or indirectly produce value for people, including ecosystems, species, fresh water, land, minerals, air, and oceans, as well as natural processes and functions. To estimate the supplied or the potential supplied value from natural capital, we should now search inside natural capital and assess the ability of a given ecosystem or of an ecosystem asset to generate a specific ecosystem service or a set of ecosystem services. All this in a sustainable way. This ability is called ecosystem capacity. To assess this capacity, a set of ecosystem services indicators is needed as the basic tool to properly estimate current and future ecosystem services supply. The use of indicators is crucial because they provide measurement units for scenario building and modeling, and by this diagnose the best possible way for sustainable management and the consequences of an improper decision, of an improper possible decision. As in every assessment, and especially when it has an interdisciplinary character, as the ecosystem services assessments, a commonly accepted classification framework is always needed. One of the most recent and commonly used frameworks is the Common International Classification of Ecosystem Services, the CISES classification, created by Roy Hayes Young and Marion Potzin. The CISES classification distinguishes ecosystem services in three major categories: provisioning services, regulating and maintenance services, and cultural services. In the following slides, I'm going to further analyze each one of the major divisions, each one of these categories, and I'll give you also some characteristic examples of their contents. At first, we're going to deal with the provisioning services. Provisioning services include all material and biota-dependent energy outputs from ecosystems. They are tangible things that can be exchanged or traded, as well as consumed or used directly by people in manufacture. Inside the provision services category, three major divisions are recognized: nutrition, materials, and energy. Nutrition includes all ecosystem outputs that are used directly or indirectly as foodstuffs, including potable water. Provisioning of water is either attributed to nutrition for drinking or materials for industrial use. It is considered as an ecosystem service because its amount and quality is at least partly steered by ecosystem functioning. For this reason, seawater is not included. Materials. Materials, referring to biotic materials, are used directly or employed in the manufacture of goods. And finally, energy by biomass, which refers to biotic renewable energy sources as well as to mechanical energy provided by animals. Here, in the first two images, you can see the supply of food and biomass from ecosystems. In the third picture, timber production as a raw material is presented. And in the last image, here, you can see pellet production as a biomass product for energy production. The second major category of ecosystem services in the CITES classification system is regulating and maintenance services. Regulating and maintenance services include all the ways in which ecosystems control or modify biotic or abiotic parameters that define the environment of people. This category consists of three major divisions: mediation of waste, toxics, and other nuisances, mediation of flows, and maintenance of physical, chemical, and biological conditions. Beginning with the first division, mediation of waste, toxics, and other nuisances includes the services biota or ecosystems provide to detoxify or simply dilute substances mainly as a result of human action. Mediation of flows, which includes air, liquid, and solid masses, this covers services such as regulation and maintenance of land and snow masses, flood and storm protection. Maintenance of physical, chemical, and biological conditions. This recognizes that ecosystems provide for sustainable living conditions, including soil formation, climate regulation, pest and disease control, pollination, and the nursery functions that habitats have in the support of provisioning services. In these images, some characteristic examples of regulating and maintenance services are presented. Here in the first image, we can see a wetland which helps to detoxify and filter fresh water from the surrounding agricultural activities wastes. This second image presents a city park with large trees which help to mediate air flows and local climate by regulating temperature and moisture. Here in the third picture, we can see a coral reef which helps to the protection of the marine biodiversity and the production of organic matter. Next, we can see a hummingbird and a butterfly feeding from a flower, and by this acting also as pollinators. In the last image, we can see one of the most characteristic functions of mangrove forests, which is coastal areas protection from waves and floods. The third and last major category in the CITES classification system is cultural services. Cultural services include all non-material ecosystem outputs that have symbolic, cultural, or intellectual significance. Within the cultural service section, two major divisions of services are recognized. First, the physical and intellectual interactions with biota, ecosystems, and land seascapes. And second, spiritual, symbolic, and or other interactions with biota, ecosystems, and land seascapes. These two cultural divisions can be broken down further into groups, classes, and class types. This hierarchical classification allows these to be distinguished using criteria such as whether it involves physical or intellectual activity. In these images, we can see some examples of cultural services. Moving from left to right, we can see two hikers enjoying a mountainous lake and the view of a waterfall, people swimming and relaxing during summer at a lake area, or here we can see a couple sitting isolated in a dense forest enjoying nature. Cultural services include also high adrenaline interactions, such as this shark diving experience in the Red Sea, or relaxing rides, as captured in this image that shows a man wandering in a mountainous shrubland. In this slide, we can see the SISES classification matrix in which the sections, divisions, and groups are included. We can see all the previously described categories and their main groups in the third column. This is a simplified version of the SISES classification matrix. You can find a more detailed version that includes more detailed classifications for each group in the SISES website. There you can find also all the updates for the classification scheme as well as a technical guide for its practical implementation. So if you need more information, please visit this site. Now I am going to give you an example of all of what we have already talked about, using as a case study a national park in the Mediterranean in Greece. Here in this image, you can see an aerial photograph from the Natura 2000 protected area of the Strophylia and Kotiki Wetlands National Park in western Greece. As you can see, the area consists of forests, wetlands, agricultural area, and coastal dunes. So here follows an example of the different sections of ecosystem services applied by the area and its different ecosystems. As you can see, provisioning services include wood collection for heating, resin harvest from pine trees, and water for irrigation. Regulating and maintenance services include water filtration by the wetland, coastal protection from wind and waves, biodiversity maintenance, and habitat maintenance for pollinators. Finally, cultural services include recreation in nature, for example, walking in forest, picnic, swimming in the sea, environmental education, by organized tours from the local management body, scientific studies in the national park. As you have already realized, ecosystem services can be distributed in space and time, depending where, when, and who uses them, as well as where and when ecosystems provide them. This image presents a river basin of a mountainous area where various services are provided by ecosystems. For example, river basins' water can be used locally on the mountain as irrigation and drinking water for the local population and for the animals, or it can be simultaneously used miles away at lower altitudes for the same purposes, for example, to cover water needs of a small city. The same goes for timber production or food production by livestock or agriculture. Other services can only be provided locally. For example, cultural services such as trekking in nature can be only supplied at local level inside the ecosystem. Others have also not only spatial but temporal restrictions. Skiing, for example, can be enjoyed only at the mountain tops and only during the snow period. One of the best graphical representations for understanding the temporal distribution of ecosystem services is made in this infographic created by Carlos Guerra et al. in 2017. In this image, time is represented as a year, using a large deciduous tree as the ecosystem. So, during spring and summer, the tree provides climate regulation services by absorbing heat and solar radiation with its leaves. It also provides a nesting place for migratory birds, protects surface soil from overheating, and provides a nice place for recreation, for example, for picnic. During autumn and winter, the same tree provides a set of different services, such as soil protection via its dead leaves already fallen to the ground, which also provides organic matter through the dead leaves to the upper soil horizon. As you can realize, ecosystem services providing areas can be in many cases the same or different than the benefiting areas. In these figures, you can see the different types of ecosystem services provision among service provision areas and service benefiting areas. For example, here in figure B, we can assume that the benefiting area is a big city, a mega city, which acts as an ever-demanding consumer of the provided services from all surrounding natural and rural areas. A good example can be also made for figure F. The service providing area and the service benefiting area can be two different countries, and thus a road or a rail network is needed to transfer the services, for example, to trade olive oil from the Mediterranean to Central European countries. All these cases depicted in these figures can be used for interpreting local, regional, national, and global ecosystem service provision, demand, and supply, and each ecosystem service assessment should identify these spatial and temporal relations and trends in order to provide reliable results.